All right, welcome everyone. So let me share my screen. Here we go. Right. So I'm going to discuss question number 6, 7, and 8 in this video. Okay. This is an application of calculus, actually optimization problem. You can find a minimum time taken from, to travel from A to B. Okay. So you can read the question. Take your time. It says a man launches his boat from point A on a bank of a straight river, 3 kilometers wide, and wants to reach to point B. So basically, the man need to start from here and go to B. So there are three options. He could go. He could draw his boat directly across the river to point C, like here, and run, okay, to point B. Or he could draw directly to point B, or he could draw to some point D and then run. Okay. So the question asks, you have to find out what is the best option. Okay. So this asks if he can draw 6 kilometers per hour. So that's the speed of speed he can draw, or speed of the board, you can say, and he can run 8 kilometers per hour. Okay. So the question asks, where should he land to reach B as soon as possible? Okay. So, or if it is possible, he can directly row from A to B. If that is the case, he can minimize the time. That's okay. You can. So basically, you need to find the time taken each of these options and find out what is the minimum situation. Okay. Um, Right. So let me find the first option. So if you talk about option one says you go from A to C and C to B, run. Okay. I call it option one. So the time from A to C, 3 kilometers. So time is the distance over speed. Okay. Write it. Time is equal to distance, distance over speed. Okay. Okay. So distance is 3 kilometers. Here he row the boat, so it's 6 plus, and he has to run 8 kilometers down from C to B. So the speed is 8. So basically it's like 1.5. Is it correct? Okay, let me see. 3 kilometers, yeah, let's divide by 6. Yeah, 8 kilometers you divide by 8. Okay, so it's 1.5 hours. For option B, or options, let's say options 2. Okay, for option 2, it says he could row directly to B. Okay, or he could row directly to B. So in that case, you have to find the distance from A to B, the length of A to B. You can use Pythagoras theorem. So it's like the hypotenuse. So it's 3 square plus 8 square over square root. Okay, because this length is 8. And this, let me use a different. This is 3, this is 8. So you can get the length from A to B. So it's 64 plus 9, which is 73 square root. So the time is, the distance is 73 square root over, he directly row from A to B. So the speed of the boat is 6. Square root of 73, I can quickly check that for you. Okay, I'm going to check that. So I need the number, find out what is the minimum time taken. Square root of 73 will be 8.55 approximately. And if I divide by 6, I will get 1.43. Okay, so it's less than the first option. Okay. And third option, third option, so I'll just that option here. Option 3, you can say, okay, so he can swim to certain distance, like, somewhere here, D. So can I get a different color? Let me see if I can. Yeah, here you go. That's okay. And maybe green. Okay. So I really need the eraser. So let's see. Here we go. So I'm going to erase everything. And you can think, change it. Oh, here, I think it's good now. Let's start. That's all. All right, he can start from A and run to D. So A to D, and then D to B. Okay, D to B. So you can choose this length to be X. That means he land at point D, which is X distance, X kilometer from point C. Okay, you can choose X from here if you want, but it doesn't matter. So it's really the distance from A to D is, if I take the time as T3, the distance from A to D is really 3 to the power 2, because that's the length from here to here, the width of the river. And this is X. And if you take the square root, you get the length from A to D. Okay, this length. Okay, and divide by, he raw that part A to D, so it's divided by 6 plus, and then he run 8 minus X distance, because it's total 8. He has to run only 8 minus X, which is divided by 8. Okay, that's the time. If he, row the boat to certain point in between B and C. So let's see, we can minimize the time. We're going to find so this is the time. Okay, this is the time, but I'm going to minimize the time. Let me see. Yeah, I'm going to minimize the time and try to find where he should land such a way that he can minimize that time. So which is, I'm going to find X such a way that he can minimize the total travel. So I'm going to differentiate T3 with respect to X. So I can take 1 over 6 out. This is 9 plus X to the power 2 minus half. You take the power 2 down, actually it's 1 over 2 there as well. And you have to take the derivative of the inside function, it's 2x If you think about this one, it's 8 over 8 is just 1. It's the derivative is just 0. It's 1 over 8. So it's basically you get 2 cancel out. So these 2 cancel out. It's x over 6 times the square root of 9 plus x to the power 2 minus 1 over 8. So that's the derivative. Okay. So if you set it equal to 0, you can get x over 6 square root 9 plus x to the power 2 equal 1 over 8. And if you cross multiply, you get 8x 6 times square root of 9 plus x to the power 2. You can cancel this with 4x 3 times square root of 9 plus x to the power 2. If you square that, it's 16x to the power 2, 9 times 9 plus x to the power. So this is 81. This is 9x to the power 2. This is 16x to the power 2. So I get 7x to the power 2 equal 81. Let me see if I do everything good. Okay. Let's divide by row. Okay, that's good. I think it's fine. So cancel out. Yeah. X and x to the power 2, it's become 16. Yeah. So I get x. X is a length, so it's positive, so I only cancel. That's my x. Okay. And you can find that point approximately. Okay. So remember, if it is a real question, you can get a numbers approximately like 81 over 7 will be 11 point something. So if you take the square root of that, it will be 3.4 approximately. So what you can do, you wanna show that t will be minimum at that point because you want to minimize the time. So what you can do, you can plug. This is your x value 3.4. You can plug something like 3.5, maybe 4 and 3, for example. So if you plug 3 to your function, your first derivative, dt3 over dx. If you plug 3, what happens? If you plug 3 here, it's let me see. So it's 3 over 6, so square root of 18 minus 1 over 8. Is this plus or minus? That's my question. I think it's this number is because the square root of 18 is like at least more than more than 4. So if you yeah, if it's this number is smaller than 1 over 8. So this is negative. So this is negative, and if you plug 4, you will get positive number. Okay, you can clearly see if you plug 4, what happened. 4 over, if you plug 4 here, it's 16 square root of 25, so it's 6 times 5 over 1 over 8. So this will be like 2 over 15, 1 over 8. But this will be 0.3. Yeah, 26, 50 is 3, 3, and so on. 1 over 8 is 0.325 actually. So this is bigger than this. This is going like 333. It's a positive. That's why I put positive here. So it's decreasing and increasing. So at square root of 81 or square root of 81 over 7, it has a minimum. Time will be minimum at 3.4. when x equal that value. Okay, so how do you find that time? You don't, I think they did they ask the time to, no, where he should land to reach the B as soon as possible. T will be minimum at when x equal 3.4. So that means he should land, oops, somewhere down from C 3.4. This is actually 3.4 or square root of 81/7. Okay, this distance. Oops. Oops. This distance. Okay. It's, I think it's clear how you get there. And if you plug that number back to the T, you can see it's less than both. I'm going to show you because it's very interesting. You can plug that and see what's going on. If you choose that x value, which is, what is x square, we got x value, we got square root of 81/7. The square of that is like 9, and I have 81/7 square root. That's the number. And you have 6. You can put that number here. This is a little bit of work, I know. This is plus, and you have whatever this number over 8. But this number, if you find, it should be less than both of these numbers. Okay, you don't need to do that calculation, but it would, you would get something less than that time. Okay, that's the point of what we do all those calculations. We should get something less than the both cases. The time will be minimum. Okay, right. Find the area of the largest rectangle that can be inscribed in the semicircle. So let me see if I can find a semicircle. Okay. Here we go. I don't know. Maybe I don't even use that. Okay. So I'm going to draw a semicircle. Semicircle means like, you know, look like this. Okay. Like half of a circle. And you could include something like, this is the rectangle. You can assume this is the maximum rectangle you can assume. Inscribe within that semicircle. Okay, the radius is just r. So this point from the 0, from here to here, is the length is r. You can put r here. This point you can choose x comma y. Then the length of, I mean area of this rectangle will be x times y, because this point is x. You can put x here, and this is y. So area is actually 2xy because I have xy, and this is also same by symmetry. Okay, so area is 2xy. But you know, if you have a circle with radius r, the formula of the circle is x to the power 2 plus y to the power 2 equal r to the power 2. That's the basic function of formula of the semicircle or circle. Okay, it's very important you get the connection between x and y. Okay, so, and you can find that y, which is r to the power 2 minus x to the power 2 over square root, and you plug that back to your y. So now you have written your area of the rectangle purely in terms of x, no y involved. So you can take the derivative. So it's like 2 because it's you can use the product rule, x times half r to the power 2, x to the power 2 minus half. And the derivative of this is minus 2x plus the square root part times the derivative of x is just 1. That's the first derivative. So I'm going to write it here with a nice d over dt. It will be similar to what you got. You get x to the power 2 minus, because these 2 cancel out. You have square root r to the power 2, x to the power 2, plus r to the power 2 minus x to the power 2 square root. And you can take the common denominator as r to the power 2 minus x to the power 2 square root. And this will be x to the power 2. The square root of this part gone because you put, the denominator you choose as r to the power 2 minus x to the power 2. So this will be plus r to the power 2 minus x to the power. So if you set the numerator equal to 0, it's negative 2x to the power 2 plus r to the power 2. That's what you get from here. And if you set that equal to 0, you get your x as r over root 2. Okay, that's your critical point. You can get minus r over root 2. That is your other point. It's enough to get 1 point. Okay, because you can consider your x distance as positive. Okay, actually x is not the width. 2x is, you can say it's like 2x is the width, height is y. So this is width and this is height. Okay, it's okay. We can find the maximum area, and they asked mainly you need to find the area, and you can find the dimension. Width is 2x, height is y. But when it asks maximum area, you can write down what is 2xy, right? So we found this number, r over root 2. But now, so let me mark it here, r over root 2. So think about what happened if I plug something more than that, like root 2 is 1 over, 1.4 or something. So I'm going to put, this is, root 2 is 1.4. So if I plug 1 point, like 1.5, so it's like 3 over 2. You can put it like a 2r over 3, which is greater than 2/3. It's like 2/3. Here you can put like 1/3, which is less than that. Wait a minute. I think I get it. Stay. Because if you plug something, I have to put like, let's see, how can I, maybe I'll do this way. dA over dt, actually dx, okay, dx. So I can write my 2 times this part. I can really write, you know, the numerator is r to the power 2, 2x to the power 2. Right? So I can write this r minus square root of 2x, r plus square root of 2x. So it's like, because it's, there's a square difference, okay? And denominator, it's always positive because otherwise the square root does not exist. So I want to discuss about what happened less than that and so on. Okay. So I can take the root 2 out here and here in these 2 factors. If you take the root 2 out from each factor, it's become 2. So 2 times 2 is 4. So this will be r over root 2 minus x. The other one will be r over root 2 plus x. I take root 2 from the both factors out. Denominator I can consider, it's just a plus multiplication. Okay. So think about this. If I plug something more than that, okay, so now I can discuss. For x, if I plug more than this is negative. because it's a negative x. This is plus. So that means this side is positive. If I put something less than that, if I put less than that, I subtract something less than this, so it's positive. This is always positive, by the way. Let me erase this one. Let me do the argument again. If I put something greater than this is always positive. Greater than, my x is greater than this number, so it's negative. So negative times positive is negative. If my x is less than this side positive, because both are positives. So it's like increasing, decreasing, so max. So that's how I really understand r over root 2, the system max. So the maximum area is 2xy. I found x, which is r over root 2, so, but I have to find y. How do I find y? Using this formula. Okay, so I can plug my r to the power 2. X is r over root 2. If I square that and then take the square root, I get r over root 2 again. Please do that calculation. So you get r over root 2. So the maximum rectangle, the area of the maximum rectangle you can inscribe in the semicircle will be r squared. Because root 2 cancel out. Because it's 2 cancel out with 2. Okay. I hope it's clear. I know it's challenging, but you can clearly do it. Okay. Take the connection between x and y and write down the area function in terms of one variable and do the calculus, get the critical point, discuss whether it's a maximum or min. In this case, maximum. You can see the last time we had time the minimum case. Okay. Right. So I'm going to discuss the last one, which is the antiderivative or integration. In this case, actually, this is kind of an easy question than the problems that we discussed so far. If you want to take the first derivative, you just need to integrate the second derivative. That's all what you want. So if you integrate this function, which is your second derivative, integration of 5 you can take out. I'm going to integrate. I will write one more time, right? Minus I can take out. Integration of cosine is sine. Integration of sine is minus cosine, because the derivative of cosine is minus sine. Derivative of sine is integration of sine is minus cosine. Integration of cosine is sine, because derivative of sine is cosine, right? And I have to have an arbitrary constant. So this is my first derivative. I get that by integrating the second derivative. That's how you come from second to first. Okay, so you can differentiate to go from first derivative to second derivative. You can do antiderivative integration to come back. And this is the initial condition given here. So I can plug the 0 for x. Cosine 0 is, 1. So it's minus 5. Sine 0 is 0. And I have c. But I know that value is given as 2. So you can solve for c. The c will be what? C will be 7. So simplify it. That's my arbitrary constant. Now I know my first derivative exactly, because I know the arbitrary constant, which is plus 7. Okay. Now I can get the first original function by taking the integration of this entire thing, like cosine x dx. This is minus, I can take out. What is the integration of 7? It's not 0, by the way. I can take 7 out and integrate. Okay. So integration of 7 is actually 7x, because derivative of 7x is 7. Integration of sine is minus cosine, so it will be plus because of this minus. So here you have minus sine x. That's your original function. But you have to include plus c. So, and then you use the initial condition given here there, and you plug 0 for x, and you get what you get. You will get 0 here because sine 0 is 0, cosine 0 is 1. If you plug 0 here, it's again gone, and you have c. But f of 0 value is 1, so c is 0. So the original function is negative sine x cosine x plus 7x because of the c0. That's the original function. So when the second derivative is given, that's how you get the first derivative. That's how you get the original function. Of course, you have to go through the first derivative. Right, so we discussed 8, 7, and 6. I think we pretty much discussed all the important questions. Please study them and find more similar questions and practice. Good luck.